I'm Timmy.
I'm Justin.
And I'm Nathan.
And this is Three Old Tech Dudes.
Ta-da!
Hey, Nathan.
Yep.
What are these toasters?
So these are oscilloscopes. These are mine. That's a Gould, and this is a B&K Precision. And actually, there we go. This is a Quimate. I don't know. This is cheap. This is a toy. But it works. So this one actually does give you a few more things because it's significantly newer. So it has like voltmeter and stuff like that built into it too. So we'll look at that here in a minute. But so right now you can actually see on this one, this is displaying a sine wave, and that one is displaying color bars off our color bar generator over there. So those of you who have seen the shirt that looks like color bars, you'll recognize that. That's it. That's what that is. Now, oscilloscopes are a tool. Just for quick definitional understanding, they're a tool used in electronics and several other industries, but generally in electronics, that allows you to see the waveform. So whether it be audio, or it be video like that one, or just a signal coming from something, that's what it allows you to do. So it allows you to measure DC and AC voltage and look at waveforms. It does not, however, measure directly anyway, measure resistance or current. There is a way to make that work, but it's beyond the scope of what we're going to do today. We're just going to go over a couple of basics on how these work. Okay, so we'll look at the front of this, and we'll give you some basic ideas on what's what here. Well, not that thing. So this is a dual trace, meaning that if you put it into dual mode, you get two actual traces here, one separate from the other. We'll leave it in single for this because I'm just going to show you this section and this section. And then it will make more sense what this does. So let's just ignore this over for right now. So you have AC, ground, DC, and then position, which is position up and down. And I need to clean that potentiometer again. You've got volts per division, and then this little thingy there, little knob that actually adjusts for accuracy, and you can adjust that for different reasons. So you've got your input. The input on these are B and C. Most of them are B and C, which is this connector. And then right now I've got this one hooked up to a sine wave generator, which is down over there. But these do have internally a 1 volt peak to peak calibrated. I believe it's a 1 kilohertz actual square wave, if you wanted to use that. So we'll just start with this section here. So you notice how big this waveform is from peak top to peak bottom. We can adjust that. I will adjust that the best I can to be starting at this center line here. These are a centimeter square each. So in this case, I've got it set to 2 volts per centimeter. I don't know what just clicked. Oh, it's your laptop. Yep. So this thing is a little under 3. So it's a little under 6 volts peak to peak. Mm-hmm. So there's a lot of different terminology you're going to throw out here, but peak bottom to peak top. That's really what we're looking at. So that is how you determine the voltage. And of course, the bigger you make this, the more you can accurately determine it. So for example, it is 1, 2, 3, 4, 5. Looks like 5 point, and these are 0.2 each on the small scale. So 5.2 actual volts, okay, peak to peak. And that's at 1 volt per centimeter. And you can simply just count it. That's all you do. So going across here, so this is amplitude, frequency. So I know this seems boring, but these have good uses for a lot of things. Now, you can, of course, look at like a microphone output in this and see, your voice and all that kind of stuff where you saw like in museums and stuff like that. They'll set one of these up and let you play with them. So the frequency this way would tell you the frequency. This is a time-based oscilloscope, so everything is in sweep time per centimeter. So to figure time from frequency, you literally just invert it. So you take 1 over time gives you frequency. So in this case, we're going to look at bottom peak or top peak, doesn't really matter which, bottom peak to bottom peak. And for ease of doing this, I'm going to put this right in the middle. Move that over just a little bit so I can see it. And then I'm going to move. Yep. Nice. That's why it wasn't very being happy for me. There we go. I'll put that at a peak. All right. So now I've got this peak at this point, or should be anyway. And then this peak is at approximately that point. Pretty close. So you take 1, 2, 3, 4, 5, 6. And I keep hitting things. So 6 and change times that. And then you do an inversion of that, and it gives you the frequency. These scopes, because this and that Gould are actually kind of old. Mm-hmm. This one I think is from the late 70s. Actually, I think both are from the late 70s, maybe early 80s. I bought that one from an auction at ITT when they were getting rid of stuff when I was there in the 90s. And this one I actually bought, Justin was with me when I bought it. And it was an adventure.
We bought a box.
We bought a box that was approximately...
Nathan bought a box.
Well, yeah. So it was a box. It was about, 4 foot by 4 foot by 6 foot maybe? Let's say about 6 foot tall box of scrap. And it was stacked with a ton of these.
It's like a watermelon container.
Oh, my. Yeah, it was big.
From the grocery store.
Yeah, sitting on a pallet. So we had them put it, we bought this at school auction. And we had them take their forklift and put it in the back of the truck. And then we took it over actually to my church and unloaded it in an area that we could kind of sort things out a little bit where we weren't in the middle of anyone's way rather. Yeah, and there was a bunch of these and a bunch of single trace versions of this. 14 or whatever touchscreen monitor. It was funny though. I wound up bringing a lot of this stuff to our Hamfest locally, which we'll show you a picture of now. And sold off a bunch of the dual trace. Actually, I sold off all the dual trace except the ones that we actually kept really for us.
Quite a few of those.
And it wound up paying for itself just on those, which is funny.
That's fun.
So the touchscreen monitors are old point of sale or POS systems. That's what POS actually means. Point of sale.
It's a Hamfest success story.
Yeah, it was actually pretty good. I've never actually bought something and then made money on it.
Right.
Wow,
I still got to
that's
keep
a new
few
concept.
of them too. Yeah.
Wow. So anyway, but back to this. But these are old and they don't give you anything except that. They just give you that simple way of information and nothing else. Okay, so this is a modern digital-ish oscilloscope. It's certainly running, and you notice it's giving you all kinds of other information. So if we put this on here, yeah.
Change your adapters.
Yeah, I was using it for something else. Sorry. So I'm going to go in here, and I'm square waving this thing big time, so I'm going to cut that down to 1 volt per division, and we're going to go with frequency. Come on. And this one, of course, gives you much other. There we go. Okay, so I think that other noise was actually AC getting into the thing because it's probably that's an old meter or an old generator we're using. Sure. All right, so I'm going to go ahead and hit OK to freeze it, which is something you can do on this. You can freeze it, and then it tells you up in here volts, frequency, The frequency is 83.661 kilohertz. Duty cycle is almost even. Vmax is 2.51 volts. Vmin, which is min to max, because remember it's a sine wave, is 2.43 negative. So it should give you a volts peak to peak at 4.49. It's actually, these probably need calibrated. This is probably a bit more accurate.
Sure.
But I can go in here and I can adjust, because that's actually bopping around 5. Yeah. Sometimes a little bit better. You notice it actually square waves too. That's actually kind of funny. And it gets up here and goes, ah! It starts freaking out. Something like this, though, is really handy. It has limits. It is not as high a frequency capacity as this one. I had to build it. It was a kit.
Oh, that's really cool that it's a kit. I love kits.
Yeah, and it was a fun little kit. And you notice I can take that off and it's still there because I've
'cause you
pushed
saved it,
hold. Yeah.
Something
And
not
it's
available on these older scopes here.
Yeah, and these old scopes,
Once you unplug it, it's gone.
yeah, once you unplug it, it's gone. Now, that being said, this age of scope did have the ability to store stuff. This one did
Storage
not.
scopes, right?
This
That's
is
not what
not.
this is.
Yeah, this is not. However, that is. That is also my old scope.
Yeah. Vacuum
That
tube
has this-
beast.
Yeah, it's definitely a vacuum tube beast. So that thing does actually have storage on it.
That's cool.
It is not the kind of storage you'd think of, though. It is very, very analog-ish, like burn-in looking horrible thing.
Interesting.
But it works.
Sure.
So this is the basic way you can figure out frequency and voltage, peak to peak. Now, DC has the same effect. So if you take I'm going to undo this and set you there. Hope you don't fall. So if we go to DC, or I'll flip to ground first. Set ground here. So if I had a DC source on this, I could flip to DC. It would then go up as a flat line. Mm-hmm. And of course, it can measure DC with AC floating on top of it, which is called a DC offset of that.
There's actually a follow-up video to the Commodore power supply repair where I use the same oscilloscope and actually demonstrate that. So
Yeah.
If you want to go, well, look there, you can see that there, actually.
Yeah, so we'll put a link to that
Yep.
there. So this will measure DC voltage and AC voltage at the same time, which is pretty cool. This will, of course, do that same thing too, in a slightly different way, but it does still the same thing. So what you're going to do is typically when you're looking at this, you will want to, because if this is, obviously you can't tell what that is, and you're adjusting this over and over and over until you get to that. So let's look at something else. So if you want to unplug that and hand it and just give me the cord. Okay. So we're now looking at video, and of course it doesn't look anything like video.
No.
And the reason it is because we are not triggering properly, which I want to go to probably be video. And you notice I'm way, way too zoomed in. So I'm going to go back out. And you notice this one actually has a lot cleaner.
It does.
Honestly, I've gone through this one and actually cleaned this thing up a little bit. So this is what TV waveforms actually look like back in the analog days. So what you got, your front porch, your back porch, you got your 3.579545 megahertz. That's the actual frequency of the color burst. In Europe, it's different. PAL, it's different. And I don't, it's like 4.4. I honestly, I'm sorry, I don't know off the top of my head. I used to, but it's been a while. So the frequency of this is your horizontal frequency, which in a TV set, an old style TV set, it was, they used to say it was like 15 kilohertz across, 15 kilohertz scan this way, and then 60 hertz going down. It's actually wrong. It's 14.975 or something. I'll look that one up and put that down here. Going across, and it's actually 59.945 going down. And the reason it's not 60 is because in the United States, that's our power system.
That's true.
So if it was at exactly 60, and honestly, most TVs will probably work with that anyway, but if it's 60 and there's an interference issue, it will actually cause all kinds of warpy images and everything else, and they want to keep it separate. That's why it's not the same. These are old TV tricks that guys taught me from years ago. I will be honest with you.
Perfect for 3 old tech dudes, though.
Yeah, and that's just so. If you want to see what dual trace looks like, we can actually run both at the same time, and then. But keep in mind, this frequency is
the same, or different.
The time's a little different. But if I adjusted the time on one to be closer to the other, you could actually see that.
That wideband is just the waveform of the signal generator.
Yeah.
Crazy out of sync.
Should actually. Let me adjust that so it's the same. Hang on.
Okay.
I'm going to bring up the other beast here. This is my very, very old. This poor old thing. So we're going to adjust the frequency where these are actually pretty close to the same.
Getting there.
So I'm never going to be able to get it exactly right, mainly because they are not synchronized.
No.
So I can do like the best I can do here and guess. And might be able to make it do that. I don't know. Well, in this one, the first input is typically your trigger. You have external trigger, and then the first one, and your second one is if you only select your second one.
Sure.
So if you're on both, it's always A.
Okay.
So I'm going to try and adjust this manually so we can sort of get it about the best I can do. So that's a harmonic approximately. And the reason this looks like this, anyway, is this frequency going through here, which is from this, is actually a harmonic of the actual horizontal frequency. It's probably not right. So I'm going to guess it's not. And we're going to go up to 15,750. Which I believe should be
Hey, looky there.
that's about right.
Yeah.
And yeah, if you want to be, it's
It's
right
getting
there. So,
closer. As best as it
Yeah.
can do off
yeah.
Channel
So
A.
that's it. I'm manually adjusting this to kind of sort of keep it in the right.
changing
Angle.
the
Sorry
signal
about the
source
mic.
itself. Yeah.
Yeah. So yeah, it's not going to be perfect because I'm not that good at getting it synced. But anyway, you get the idea.
Yep.
So that's how dual trace actually works. It allows you to see two signals at once. Or you can go to this, and it actually is X one way, Y the other. And of course, it's
I
not
didn't know
really.
that.
Yeah. So you can do a trick. Go back to just A. So if you had an issue where you had to trace or wanted to see a signal across something, you would use one probe on one side, one on the other, and measure across it, and that's where you go to like X, Y, or in this case it just says B, but that's the X on one, Y on it. And that one actually says X, Y on it. And that will then give you a difference of the two,
Okay.
which is kind of neat. That's not used a lot, but it can also be used in a few other tricks. If you have a bad, like, hot ground, it will sort of get around it. Not right, but it will sort of do it. I don't recommend that, by the way, either. But you've got internal external source. So here's your external trigger. Ground, which if you're in, like, England, U.S., we'll call it ground. There you call it earth. It's the same thing. There's your calibration. Power on and off, which is a knob on this instead of switch. Intensity is literally just brightness. Focus is exactly what you think it is. And then, of course, the second one also has AC and DC offset and a position, just like the same way. So if you go to B and I want to adjust the position, DC offset, or both, you can adjust, separately. And simply put, that's how this works. Now, the neat thing is most oscilloscopes have a very high input resistance, and that does make a difference when you're looking at circuits that are touchy about what's connecting with them. Your probes typically will have a divide by 10, or sometimes they call it X10, but it technically is a divide by 10 on signal, or in other words, multiply by 10 to make the answer correct. Or that's the other way around. No,
demo device for that.
It divides the power, or divides the voltage in half, or divide by 10 rather. So this is 1x 10x. Yeah, so 1x 10x. 1x is straight through. 10x is you're actually dividing the input power or voltage rather, not power, voltage, not power, voltage. You're dividing the input voltage by 10, so it is effectively 10 times what it's reading there because you're looking at it in the other
So
end.
if you're expecting 2 volts, you'd use 0.2 in that case. So
Yeah, so if, and I'll show you what I mean. So if you go in here, we're going to look at B, and we're going to clip that on, and we're going to set that up to where we can see it. So this is slower too. So if this is on divided by 10, there's straight through, or times 10. So times 10 divides it down. So 0.2, it's actually 2. So if you go up to 2, you'll see the same looking thing.
that's right.
So 1 looks like nothing. But if we go to 0.1, it goes big. But that's how that works. So these are scope probes that allow you to clip on, or you can take
This is
this
a set I have.
off.
I got them off Amazon, pretty affordable.
Yep.
So. I did not know.
Mine are unscrew. So this is the actual connection in the middle. All this is a clip
It's a
on.
little clip deal. Yeah.
Yeah, this is just a clip. It's think of it like an alligator clip. It's just so this will go in here. Boop. It can stay there. So this is your reference to calibrate.
Yep.
And I'm not saying it's in perfect calibration. I mean, it's old. It's probably not, honestly.
I
But
felt like mine was pretty close. I checked it with a multimeter digital, and it seemed mine was pretty darn close still. So.
yeah,
Old but working well.
that is the simplistic way to use an oscilloscope. Now, mind you, there's a lot more to it than that, but that'll get you going starting with.
Show the effect of fading the video out.
Yeah, sure, go for it.
So if you take the color bars down, it collapses back down, and then what is this you have left?
So this is just a black screen. So you have your front porch, back porch, and you have your color bar.
Fade it back up.
Yeah.
You still have your.
So the neat thing, like that's color bars. So back in the day when HBO had their really, really big logo that was before every movie and whatnot, if you looked at that on a scope, you could read HBO. It was big enough you could see it. That was the coolest thing ever because I was like, oh, I shouldn't be able to do that, but it does. It's just the way they'd done it. It actually looked right and you could see it.
So even if you change the color, you can see, what is it, the luminance?
Yeah, you're looking at the brightness, the luminance of it. Yeah.
So each time I change a color,
Yeah. And your color is basically flickering through in the background of this. And this does a pretty good job of kind of masking that out. But yeah, that's how that's working.
it's cool.
Yeah.
After our bars.
Yep. So you can use this as a service monitor for video. Apparently someone came up with a way to make this also a vector scope. I've never seen that, so I don't know. At this point, I probably wouldn't do that. But just buy a vector scope. They're nothing now.
I think it was interesting that you actually found one of these in the pile that had never been used, right? It was still new in the box.
Oh, new in the box, yeah. We found one new in the box. It's still in the box, unopened.
That's wonderful.
With the styrofoam around it and the plastic bag and everything.
Yep. Well, the funny thing is we also found one from the 1950s that was frequency-based instead of time-based.
Is that the Heath kit?
No. That's actually a decent, relatively. Those are in the 60s.
That's in my collection now.
Yeah,
it's going to get cleaned up for a future video. I think it's really cool.
It's full of vacuum tubes.
Yes, heck yeah, tubes.
Nothing wrong with that. So this is the basics of how it works. This is a modern style, even though, yes, it's very, very old. It still works in the same way that a more modern oscilloscope works. New ones, of course, just give you a lot better displays, kind of like this one does, where it gives you a bunch of extra data and things like that. So don't be afraid to use an older oscilloscope to do stuff like this. If you want to look at audio waveforms, it's really, really good for that. These are good up to even just old style video.
Yeah, because Justin and I got one of these from Nathan. I had always thought scopes were cool. I'd never owned one.
Yeah, he does.
And so it was kind of a, yeah,
Two,
I
actually.
have one of these, as does Justin. And we're like, you need to teach us your ways and some of this. Because he knew about this video stuff, and I'm like, this is so neat.
Yep.
I want to know more. Now I know. And so do you.
Yep. So if there's other things you've done with oscilloscope or things you like to see with an oscilloscope, see how to do, mind you, I just touched on it and pretty basically here, honestly. But, if you've used an oscilloscope, what's the first scope you ever used? Mine was actually one of these. I don't know if it was this exact one, but when I was in the vocational school program at our high school for electronics, shocker, these were the scopes we actually had. These not this model, these actual scopes.
And that was in the late 80s, right?
That was in the late 80s.
Late 80s, yeah.
Odds are I touched this actual scope, this physical piece of hardware here back in the 80s.
Well, it's held up well for a bunch of teenagers touching it over the years. So all of them have for the most part.
And this is B&K Precision. And honestly, I went through all of these, and the only one that had a problem turned out not to be a severe issue. It really was a corroded connector.
That's impressive.
And I got every one of these up and running. I didn't have a single dead one. We thought we did have a dead one. I'm going, one failed. Okay, yeah. But no, it was actually just a connector was corroded, and I cleaned it right up, and it worked. These old B&K Precisions, they hold up. So if you like this video and want to see more like it, make sure you hit the like button. And if you haven't subscribed yet, make sure you subscribe to us because we're trying to release more and more of this stuff. Yep. We're really trying to get the numbers up because it makes doing this a lot easier, honestly, on us. Also, hit the notification bell so we release videos. We try and release them once a week, but sometimes it's not quite so good. We're human. We still have to work.
Been doing good lately.
We're doing pretty good.
You've been doing good lately.
I enjoy
it. Yeah. Make sure you leave a comment. We do read them.
We do.
We really do.
Try to respond as well.
Yep.
So, may take us a little bit sometimes, but we try to respond.
Yeah, we are human. We're having a merch store come out relatively soon. Hopefully, maybe the next month or two. I'm not sure.
All right. Well, until next time, I'm Timmy.
I'm Justin.
I'm Nathan.
And this is Three Old Tech Dudes. Thanks for hanging out with us here on Three Old Tech Dudes. Please subscribe to us here on YouTube for more tech old and new, tinkering at the workbench, repairs, ham radio, electronics, computers, and more. Please like this video and share 3OTD with your friends to help us grow the channel. We tweet at 3 Old Tech Dudes 1 on Twitter, and you can keep up with us on Facebook. Just search for 3OTD and look for our logo. Thanks so much for watching.